Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths A. We have started a discussion with the chapter partial fractions. What we learned? We learned the 4 types, that is when the given function is proper, first thing. 4 conditions are of only proper fractions. That too, the first 2 is only reducible and the next 2 is only irreducible. How? For reducible, one is repeating and one is non-repeating. Type 3 is repeating, irreducible, non-repeating, irreducible, and type 4 is irreducible and repeating. Okay. These are all of only proper fractions. So, what if the given function is improper? Improper is the numerator degree is not less than degree of the denominator, that is either it should be greater or it should be equal. Okay. Let us say f of x by g of x is a fraction, then we can have 2 cases, that is degree of numerator is equal to degree of denominator, right. What is one more condition? Degree of numerator is still more than degree of denominator. Okay. So, how do we solve it? So, since it is an improper fraction, we have to convert it into proper fraction. How do we do is just we will divide, we will write in this way. We will write f of x as some constant into g of x plus some remainder r of x. Okay. What is this k? K is nothing but coefficient of highest degree term, okay, coefficient of highest degree term or else degree term divided by coefficient of highest degree term in denominator, okay, and here it is a term of numerator. Similarly, if the numerator ka degree is more than denominator, then we will write f of x by g of x is equal to some quotient plus remainder by g of x. What is this q? Whenever we have the numerator number, we will just divide the polynomial and write the quotient here and the remainder here. Here we will write only some constant which is equal to this into g of x plus r of x. So, that when we divide, this g of x will get cancelled and we will be left with r of x, or else we can write f of x by g of x as k plus r of x by g of x, right. Here we will have a constant and here we will have a quotient. Clear? Shall we do few problems of this kind? Let us do. See here, the question is given as resolve x power 4 by x minus 1 and x minus 2 into partial fractions. Now, first tell me whether it is proper or improper. It is improper. How? The degree of denominator is only 2 and the degree of numerator is 4, right. It is not only improper, but it is of this kind where we have to divide the whole polynomial. Okay. How do we write? Just we will write f of x by g of x is equal to quotient plus remainder by g of x. In order to do this, we have to find the quotient first. Okay, shall we divide? Now see here, x power 4 by, here it is x square minus 3x plus 2. Since it is not the mandatory thing in your exam, I have written it directly. X square x power 4, let me multiply it with x square. It is x power 4 minus 3x cube plus 2x square, right, minus 3x cube plus 2x square. Subtract, this both will get cancelled, this is 3x cube minus 2x square. Next, here it is x cube, here it is x square, let me multiply with 3x, okay, 3x into x square, that is 3x cube. Next, 3 3s are 9x square, 3 2s are 6x. Then let us subtract, these both will get cancelled. 9 minus 2 is 7x square minus 6x. Then again 1 here it is 7, 7x square, 7 3s are 21x plus 14. Done. Minus plus minus, these both will get cancelled. 21 minus 6 is 15x minus 14. This is my remainder and this is quotient. So, I can write the given fraction as, what is this q of x? X square plus 3x plus 7 plus r is 15x minus 14 divided by x minus 1 into x minus 2. Now, if you observe, is it proper or improper? This term is a proper fraction. How? The denominator, even if we multiply, will get it as x square and the numerator will have only x power 1. So, we have to find the partial fractions for this. Okay. Now, again the same story starts. Let 15x minus 14 by x minus 1 into x minus 2 is equal to a by x minus 1 plus b by x minus 2. Let us simplify it. What do we get? 15x minus 14 by x minus 1 into x minus 2 is equal to, LCM is x minus 1 x minus 2, a into x minus 2 plus b into x minus 1. Cancel these both. Then put x equal to 1, what do we get? 15 minus 14 is equal to, this term will go, I will be left with 1 minus 2 is minus 1. Therefore, a is minus 1, right. I am writing everything directly because we have already did more than 3 to 4 problems of the same stories. Okay. See here, 15 minus 14 is 1, a is minus 1. Next, put x equal to 2. 15 2s are 30 minus 14. Here this term will go, b into 2 minus 1 is 1. Therefore, b is equal to 30 minus 14 is 16. Right, we got the values of a and b. Just substitute in that this term. Then I will get the whole term as, let me write it as 2. Therefore, the given term x power 4 by x minus 1 into x minus 2 becomes as x square plus 3x plus 7 plus, this term is nothing but this, right. What is a? Minus 1 by x minus 1 plus 16 by x minus 2. Is it? Is it okay? This is in the form where the numerator ka degree is more than the denominator ka degree. Then we have to write it as f of x by g of x quotient plus remainder by g of x. In order to do that, we have to divide the polynomial. Clear? Shall we move on to the next problem? Yes, do. Look at the next question here. Here he is asking us to resolve this polynomial into partial fractions. First step, check. Here it is x cube and here x minus a, x minus b, x minus c. Here if we multiply the denominator, we will get it as x cube. Numerator is also x cube. Therefore, it is a improper fraction, but both the degrees are same. So, we will write find the factor k. How do we find the factor k? Before that, let me write f of x by g of x is written as k plus r of x by g of x. What is k? The coefficient of numerator by coefficient of denominator. Even if we multiply all the terms, we will get only one. If you observe here, x, x, x. Therefore, the value of k is 1. Okay. So, we will be left with f of x by g of x is equal to 1 plus r of x by g of x. So, we can directly write this term, whatever the term may be, this can be written as into partial fractions. So, we will write x cube by x minus a, x minus b, x minus c as 1 plus a by x minus a, b by x minus b, c by x minus c. Is it okay? So, let us simplify it. Fine. This will be x minus a, x minus b, x minus c. What is there in the numerator here? Nothing. So, we have to write all the 3 terms, x minus a, x minus b, x minus c. What about a? We do not have these 2 terms, we have to write these, x minus b, x minus c, plus what about this b term? Let me write it here, b into x minus a, x minus c. What about c term? X minus a, x minus b. Now, these both denominators will get cancelled. So, I will be left with, let me write it clearly, x cube is equal to this all terms, x minus a, x minus b, x minus c plus a into x minus b, x minus c plus b into x minus a, x minus c plus c into x minus a, x minus b. Now, what we have to do in order to find capital A, capital B, capital C? Only substitution. Put x equal to a. What do we get? A cube equal to, this term will go, these 2 terms will go. We will be left with a into a minus b into a minus c. I will directly write a is equal to a cube by a minus b into a minus c. Is it? Similarly, let us put x equal to b. Put x is equal to b. I will be left with b cube is equal to, again this term will go, this term will go and these terms will be go. X is equal to b minus a into b minus c. I will get b is equal to b cube by b minus a into b minus c. Next, put x equal to c. C cube equal to, again we will lose this term will be left with c into c minus a into c minus b. Therefore, c is equal to c cube by c minus a into c minus b. Over, substitute ABC values in this first equation, write it properly. Therefore, the partial fractions are 1 plus a cube by a minus b into a minus c into x minus a, okay, plus b. What is b? B cube by b minus a into b minus c into x minus b plus c cube by c minus a into c minus b into x minus c, right. We have did 2 varieties of problems till now, yes, but make sure that this term should be correct and you should not miss any of ABCs. Clear? Is it okay? Fine. Shall we go to the next problem? Let's do. Look at the next question here. He is asking us to find the coefficient of x cube in power series expansion of this term. Okay? Just look at this, whether you know or you do not know, this is a fraction. So, we can do partial fractions. First do that, then we will discuss about the question. Okay? This is, let 5x plus 6 by x plus 2 into 1 minus x is equal to a by x plus 2 plus b by 1 minus x, isn't it? So, let us solve it. LCM is, or else let me write it directly, 5x plus 6 is equal to a into 1 minus x plus b into x plus 2. Put x is equal to 1. Okay. What do we get? 5 plus 6, 11. This both will get cancelled. I will get it as b into 1 plus 2, that is 3b. b is equal to 11 by 3. right? Next, put x is equal to minus 2. I will get it as minus 10 plus 6, that is minus 4. We will lose this. I will get it as minus 2 minus 1, that I mean 1 plus 2, that is 3a, that is a is equal to minus 4 by 3. Is it right? So, substitute in the term, once again check here, 5 plus 6 is 11, here 1 plus 2 is 3, 3b equal to 11, b equal to 11 by 3. Next, x equal to minus 2, minus 10 plus 6, 6 minus 10 is minus 4, here minus 2, I mean 1 minus 2 minus plus 2, that is 3. Is it okay? So, from 1, what do we get? Minus 4 by 3 into x plus 2 plus 11 by 3 into 1 minus x. Is it okay till now? Now, we are going to convert it into a series form. How do we do is, we will write it as minus 4 by 3 into 2 plus x, okay, and not only that, we will take 1 common, I mean 2 common here, and we will write x by 2, okay, remember that particular thing, plus 11 by 3 into 1 minus x. Is it okay? Now 2 1s are 2 2s are, this will be left with minus 2 by 3 into 1 plus x by 2 whole power minus 1, and here 11 by 3 into 1 minus x whole power minus 1. Okay, we have written it as in the power series form, that is, and denominator can be written as inverse of a numerator, okay, or else numerator term can be written as inverse of the denominator, okay. So, the formulas which you have to learn as of now here is 1 plus x whole power minus 1 is 1 minus x plus x square minus x cube and so on, and 1 minus x whole power minus 1 is 1 plus x square plus x cube and so on, okay. These are the two formulas which we have to remember for this sum, okay. Why do we get this thing? We will again discuss in our binomial theorem chapter, okay. As of now, remember this. So, this is minus 2 by 3 into 1 plus x by 2 whole power minus 1, that is 1 minus x by 2 plus x square by 4 minus x cube by 8 and so on, plus 11 by 3 into 1 plus x square and so on, isn't it? So, he is asking us to find the coefficient of x cube. So, we have to take only x cube ka terms. Let me write one more term here, plus x cube and so on, okay. So, therefore, coefficient of x cube, what is it? Just we will take only x cube ka coefficient from here and there, that is minus 2 by 3 into minus 1 by 8 plus 11 by 3 into 1. 2 1s are 2, 4s are, that is 1 by 4 3s are 12 plus 11 by 3. LCM is 12. 1 plus 11 4s are, therefore, answer is 45 by 12. Is it right? Did you understand? Okay, if you want to cancel, you can also cancel. 3 15s are, 3 4s are, this will be 15 by 4. Clear? Is it okay? Fine. By this problem, we can end this chapter, partial fractions. What all we learned in this? We start with the what is a partial fraction, proper, improper. For proper, we had 4 different types. For improper also, we had 2 different variations, right? As on all, after doing partial fractions, how do we use the terms? This is one of the application of partial fractions. Clear? Did you understand? Fine. Hope everything is clear for you. Let us meet in the next session with a new chapter of 2A. Thank you.